guys, this is part 2 in a series on concavity and the second derivative test for concavity. In this video, I'm just going to go through examples. If you're trying to look at some more theory behind this, I would recommend taking a look at the first video in this series. As a reminder, the way these examples work, you want to pause and try the examples when prompted, and there are always free guided notes available at divideandconquermath.com. And also, if you find my channel helpful, please consider liking my video or subscribing to it. That's the best compliment that you can give me for providing free math help on the internet. Okay, so let's just jump right into it. I've got two examples here, and what we want to do is determine where the graph is concave up or concave down, and any points of inflection. So let's take a look at the first example. So if you watched the first video, you should kind of have an idea of how to already do this, but I'm going to go ahead and walk you guys through this. So what we want to do to find our concavity is we're going to have to find the second derivative. So pause the video and go ahead and find the first and second derivative. Hit play when you're ready. Okay, so let me write out the first and second derivative. Okay, and so there is my second derivative. So concavity and inflection points kind of go hand in hand. So what we need to do now is we need to really set this equal to 0 and see if it will ever equal 0. Spoiler alert, it won't. And then the other thing that we have to determine is if there are any places where the second derivative does not exist. So that is true, right? This does not exist at x equals 0. And so this is going to be how we actually divide up our domain to find our intervals of concavity. Now, at this point, it might also be good just to note what is the domain of this actual function. Well, the domain in this case is all real numbers, so I've just noted it as such. Okay, so now basically what we want to do is we want to split up the domain using this potential inflection point, because your concavity is only going to change at these potential points. So to set up a table, let's go ahead and do it. There's really two pieces of information I need to know. I need to know the interval, and then I also need to know the sign within that interval. So I'm going to break up this domain using this point. So this is going to go from negative infinity to 0. And then from 0 to infinity. Now, I've talked about how to split up these domains at length, actually, when we talk about critical points. So I'm not repeating this again, but I will drop a link to just kind of working with that. You should already feel really comfortable with the first derivative test and critical points before you try to go for this lesson. Okay, so the next thing that I need to do is I need to choose a test point in this interval. So one good test point in this case would be -1. Now, all I really care about is what is the sign of f double prime. So if I try to evaluate this, I can see just by looking at this and how it's going to turn out, this is already negative, and then when I take -1 to the 5/3, that will also be negative. So this ends up being positive. This is all that I actually care about. I don't care what the decimal is, and I've talked about this at length in other videos. So the sign here then, for all test points kind of in here, will be positive. So now let's do this again for a test point in here. So I'll just choose x equals 1 and do the same thing. And you can tell just by looking at this that this then is going to end up negative. So that's all that I really care about. So if you can figure this out, you can just kind of note that. Though I would recommend when you're doing this on a test or quiz or whatever, you probably want to be pretty explicit about what you're doing. The worst thing that can happen, right, is that you make a mistake. And so you just want to make sure that you show as much detail as possible. So it's like, I totally knew how to find a test point, and I totally tested it, but then I made a sign error, which is very common. And a lot of times that will kind of demonstrate to your teacher that you kind of knew what you were doing. And of course it depends on the teacher, but just a note on that. Okay, so let me clear some space. And now I can make some conclusions about the concavity based off of what I've got so far. So let me write that out. So one thing you always want to do is be in the habit of summarizing your answers and making it very clear that you know what you know. So do actually take the time to force yourself to write this out so that you have good habits. Okay, so now that we know something about concavity, now let's talk about inflection points. So I'll clear some space again. Now you have an inflection point as long as the concavity changes, which it totally does, right? It goes from positive to negative, so that's really what we need. So I know that 0 is going to be an inflection point. So then I can just summarize that. So depending on how your instructor wants it, you could just say that it has an inflection point at x equals 0, or you could actually plug that point into the original function to figure out what the inflection point is. Kind of just depends on what your instructor wants, so just something to think about. Okay, so that covers the first example. So now let's go on to the next one. So here's my new function for you. So you know that you're gonna have to take the first and second derivative. So why don't you pause the video, hit play when you're ready, and I'll show you the answers. Okay, so here we go. So I'll take the derivatives. Okay, so there is my first and second derivative. So just a pro tip here, you're gonna wanna use the chain rule when you do this. All right, so now I need to find my potential inflection points. So there's going to be no place where this function here is undefined, so I don't have to worry about that. So I just have to set it equal to 0 and solve. So if I were you, what I would do is I would look for the potential inflection points, figure that out on your own, and then hit play when you want to check your answer. So here, this will be, x is going to be either pi over 4 or 3 pi over 4. Those are my two potential points of inflection. So from here, I would set up the table. So remember, we have a restricted domain in this case, but I will go ahead and set up the table and then try to find all your concavity and points of inflection, and then just hit play when you think you're ready to check your answer. Okay, and so as I choose my test points, so I'll also just show you what you should have gotten for your signs for the various test points. So you should have gone from concave down to concave up to concave down. Now, in the interest of time, I'm not actually going to write out what your concave up and concave down intervals are. I don't want to make this video too long, but you would say, and you would state that you have a concave down at 0 to pi over 4 and from 3 pi over 4 to pi, and then you'd be concave up from pi over 4 to 3 pi over 4. Then you can also see that you actually have inflection points here, right? So I have an inflection point both at pi over 4 and 3 pi over 4, so I will write that down. Okay, and so that's kind of the idea behind this lesson. So thanks for watching, guys, and I'll see you in some other videos.